Okay, let me introduce this assignment. The goal was to simulate a transportation network between cities and apply Dijkstra's algorithms to find the most efficient routes. So we built a graph, loaded cities and distance data from CSV file, and tested the algorithm both on small graphs and massive scale networks. So imagine you are building a GPS routing system. We generated 300 cities and 10,000 connections randomly, simulating a transportation map. Each connection has a random distance between 10 and 999 kilometers. The information is saved in a field called routes.csv file. Our main goal is to find the shortest path between two cities. For example, from like DQ to CQ is 150 56. So to represent the city map, we used a city we used you used a class called graph Java. This class used an adjacent list. You can see from here adjacent list. Each edge is an object that store the destination cities and the weight. You can see from here, and we add the cities and rows use all those functions. Um, and the graph constructor takes a directed flag to support both directed and undirected graphs. What's cool is that we also included the Dijkstra's algorithms directly in this case, in this class. Here's the idea: using a priority queue and to always expand the the closest unvisited city and check the shortest distance and how we reach each city. Here's the priority. Here is the priority queue and the queue data setup. Then we loop through the neighborhood. You can see from here, and in the end we reverse the path. We reverse the path and using the prever map. And then we also build a cleaner proposed build a version called City Road Graph. You can see here, and this class focus only on the loading CSVs and computing the shortest path using Dijkstra. The key data structure is similar, and the difference is we use the city root objects. You can see from here city root object, and it's instead of this just returning a list, we return a structured result. You can see from here. So and then this is much easier to test and log. And to make it real, we use the city root processor. It read from the root CSV file and build a graph. You can see from here, and once the graph is ready, we can do all those results, and to output all those we can see from here, like to Q to I. You can test here, got the result. You can see from here to Q to I, we have the distance is 140. And then now we can just like for the heavy lifting in the graph test, you can see here we can create a synthetic graph with like 100,000 cities and 1 million edges. We generate like here from here, and we return like 10 shortest path query between random pairs. It records average query time. You can see from here, like when we run this. So yeah, so we are not only solve the problem, you can see here, and we also test how it scales, and it works impressively. We are even on huge inputs. So let's warm up. We design and build a flexible graph system in Java. Used Dijkstra algorithms to find the shortest path efficiently, and then we create both generate proposed graph and a city specific variant, and loaded real data, test the real result, and then scaled it up to 10K 100K nodes. It's it was a super fun project and help us understand both algorithmic logic and performance implications. So thank you for your time to watching this. Yeah, that's all.